Hello everyone, welcome to this video. In this video, we have to tell that for each group in the following list, we have to find the order of the group, one thing, right? We have to find the order of the group and we need to tell what is the order of each element in this group, right? This is first question. So we are given these 5 groups. So let's focus on to one by each of these groups one by one. So here our first group is Z12. You know what is Z12? It is the group of all the integers less than 12 such that we have this operation of addition modulo 12. So we have the elements starting from 0 up to 11. So how many such elements are there? If you remember the definition of group, order of the group, what is it? It is the number of elements which are present in the group. So in total there are 12 elements which are present, 1, 2, 3, 4, 5, 6 and so on up to 12. So the order here is, order of this group is 12, right? This is one thing. Now let's talk about the individual element. For the individual element, if you remember the definition of an order of an element, what is it? It tell you that if you apply this operation onto the element, how many times, so that you would get the identity. So suppose you have a element, so how many times you have to apply this operation? We are given this, right? So that we would land up at the identity of this group. What is the identity of this group? It is 0 because we are taking the addition modulo 12. So 0 is the identity. So for the element 0, we need to see 0 when added to itself, how many times would give you 0? It is just 1. So the order is 1. What about the element 1? 1 is added to itself, how many times would give you 0? You see, when you add 1 to itself 12 times, right, you would have the number as 12, and when you divide 12 by 12, right, you would have 0 as the remainder, right? So that means 12 is the order here, and it is that least number for which we obtain the identity. Similarly for 2, when you add 2 6 times, you will have 12, and 12 mod 12 is 0, right, which is the identity. So we have the order as 6 because we are doing it 6 times. Then what about 3? We are adding 3 4 times, so the order is 4, so that we have 12 and it is 0 mod 12. What about 4? We are adding 4 3 times, so the order is 3 because when you add 4 3 times, you will have 12 and it is 0 mod 12. What about the number 5? When you add 5 12 times, so you would have 60 as the answer, which when done with mod 12 would give you 0, correct? What about 6? For 6, if you add 6 2 times, you would have 12, so that means 2 is the order here, right, which is 0 mod 12. What about 7? When you add 7 12 times, you would have 84, which is completely divisible by 12, which give you 0 as the remainder. Hence 12 is the order. There is no other integer less than 12 which give you this. What about 8? When you add 8 3 times, so the order here is 3, you would have 24, which is completely divisible by 12, right? What about 9? 9 when added 4 times give you 36, which is completely divisible by 12. What about 10? 10 is added to itself 6 times, so it will give you 60. When you divide 60 with 12, you would have 0 as the remainder, right? So therefore 6 is the order here. What about 11? 11 when added to itself 6 times would give you 0 as the remainder, 132, which is completely divisible by 12. So 12 is the order. Correct? So in the first case, we have obtained all the orders. Now let's move on to the second group, U10. What is this group U10? If you remember, it consists of all the numbers which are less to this number 10, right, and which are relatively prime to this number 10. So the number 1, the number 3, number 7 and number 9 are present within U10. Here the group operation is multiplication modulo 10. So you see here you have 4 elements present within this group, so its order is 4. What about the order of its element? So here we have to see the element A. When we apply this operation of multiplication modulo 10 to it, how many times, so that we obtain the identity of the group, which is 1. It is in this case the identity is 1, right? So you see when 1 is multiplied to itself 1 time, so you would have 1, which is the identity, so its order is 1. What about 3? For 3, if you multiply 3 4 times, you would have 81. And when you take 81 mod 10, when you divide 81 with 10, right? So you would have 1 as the remainder. So you have identity as the remainder. So how many times you are doing this thing? 4 times. So 4 is the order. Similarly for 7, when you multiply it 4 times, you would have 2401, and when this is divided by 10, you have 1 as the remainder, right? So 4 is the order. Similarly for 9, 80, when you multiplied it 2 times, you would have 81, and you have 1 as its remainder, so its order is 2. Correct? So you see, we have found all the orders of the elements and the group elements here in the second case. What about the third case? We are having U12 with us. U12 means we are taking all the numbers which are less than 12 and are relatively prime or co-prime to 12. Here the group operation is multiplication modulo 12. So we have 1, 2, 3 and 4 elements present. So the order of this group is 4. This is one thing. Another thing, the order of elements. The order of elements. So we are looking for the elements such that how many times we perform this operation so that we would have 1 here, and this is the least number of times. Correct? So what about unity? When you multiply it 1 with 1 times, right? So you would have 1 as the remainder. So its order is 1. What about 5? When you multiply 5 twice, you would have 25. 25 mod 12 is 1. So you see the order is 2. Similarly, the order of 7, when you multiply 7 twice, you would have 49. 49 mod 12 is 1. So you have the order as 2. What about 11? 11 into 11 is 121. When you take its mod 12, it is 1. So therefore its order is 2 because we are doing it 2 times. Correct? So we have all the group orders and the order of group here in this case. For the fourth case, we have to look for U20. For U20, we are looking for the group in which all the elements, they are less than 20 and relatively prime to 20. So there are in total 8 such elements which are listed over here. Right? The operation is multiplication modulo 20. Correct? So the order of the group is 8 because it has 8 elements within it. Now, what about the order of each element? The order of the element 1 is 1. Similarly, you have for 3, multiplying it 4 times, right? You would have 81. 81 mod 20 is 1. So its order is, because we are doing it 4 times, so its order is 4. Similarly for 7, we are multiplying 7 4 times, so that we would have 2401. When you take its mod 20, you would have 1 as the remainder. So the order here is 4. Similarly for 9, 9 into 9 is 81. 81 mod 20 is 1. So you have the order as 2. For the other elements, 11 when multiplied twice give you 121. And 121 mod 20 is 1. Right? So 2 is the order. What about 13? 13 multiplied to itself 4 times would give you this number. Right? This number, when taken its mod 20, you would have 1 as the remainder. Correct? So its order is 4. What about 17? 17 when multiplied to itself 4 times would be 83521. Correct? So when you calculate mod 20 of this number, you would have 1 as the remainder. So its order is 4. What about 19? 19 multiplied to itself 2 times, right? So it is 361. So when you take mod 20 of it, when you divide 361 with 20, right? So you see you have, you then do it with 8, you have 1 as the remainder. Correct? So 1 is the answer here, and you are doing it 2 times, hence its order is 2. Hence we obtain all the group orders in this case, order of the group elements in case of U20. What about the last one? In the last one, we are talking about this dihedral group D4, where we are talking about the symmetries of a square. If you remember, for a square, we have these 8 elements. We had this square, right? A, B, C and D. When you rotate it by 0 degree, that is the same orientation. When you rotate it by 90 degree, we have a different orientation, right? 180, rotating it by 180 degree angle, rotating it by 270 degree angle, then taking a horizontal flip, then taking, this is the horizontal flip, then taking the vertical flip, then taking the diagonal flip, and then taking the other diagonal flip, right? These are the reflections. Now here the group operation is composition. You know that. What is the order of this group? 8, because we have in total 8 elements within it. What is the order of R0? R0 is itself the identity of the group, correct? So its order is definitely 1, right? Here the operation is composition. What about R90? R90 is rotation by 90 degrees. So in order to reach 360 degree rotation, again you have to move by 90 once, then twice, then thrice, right? And then once more. So how many times you are moving it so that you again reach back to the same position? 4 times. So its order is 4, correct? What about 180? You are rotating by 180 degree, and then you are again rotating by 180 degree, correct, in order to reach 360. So that means you are doing this operation 2 times so that you get back to the same initial position, which is R0, correct? So the order is 2. What about 270? 270, you are doing it once, right? Then we are only allowed to move 270. So next time you move by 270, you reach here. This is 270. What about the next time? Next time you move at 270 degree angle, you will reach here 270. What about next? If you go from here to here by 270 degree angle, you reach here, which is 360 degree, which is the same as 0 degree, right? So basically you are moving 4 times here. So here also the order is 4, right? What about reflections? You see, for a square, if we apply this horizontal flip, so this portion A would go to B, C would go to D, correct? So it would be like this: B, A, D and C. If you flip it again, you would get back to the original orientation, which is A, B, C and D. So you see, we are doing this operation 2 times. So hence for a reflection, and doing it again would undo the action. So therefore in this case the order is 2. Similarly for the vertical flip, if you have A, B here, C, D here, once you reflect it along this line, so it would be B, A and D, C. Once you do it again, you would have your square with the original orientation, correct? So therefore its order is also 2. Similarly for the diagonal flip and the other diagonal flip, we have the same thing. As reflections are their own inverses, so in this case we have this result. So I hope you are clear with the order of each group and each group element, right? The next question they are asking to us is, what relation do you see between the orders of the elements of the group and the order of the group? Now let's examine this thing. So here notice what is the order of group, that is 12. Order of each element, it is 1, 12. What all numbers are there? Can you see it? So once you see all the orders, we either have 1 or we have it as 2, 3, 4, 6 or 12, right? So you see the order of group is 12. So you see all of them, they are the divisors of 12, correct? This thing here. What about the second group? In the second group we have the numbers as 1, 2 and 4. So you see 1, 2 and 4 are clearly the divisors of 4. That is okay. What about the third part? 1 and 2. These are the orders of elements. So you see 1 and 2 are divisors of 4. That is okay. What about third part? You see 1, 2 and 4 are the orders of each element. So they are clearly the divisors of 8. What about the last one? In the last one, you can see that the order of elements is 1, 2 and 4, which are clearly divisors of the group element, the order of group, which is 8. Hence, in this case, we can say that the relationship between the order of the elements and that of order of the group is that order of elements always divide the order of the group. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.